Okay, now I would like to show you how to work with scenarios. So let's again open our water demands dialog, and let's create one more point demand now for firefighting demand, and let's call this fire, or let's call this fire 1, for example, and let's create one more and let's call this fire 2. So if you set multiple firefighting demands into same configuration, that would mean that you have parallel fires. So if you want to simulate firefighting demands on a different parts of the network, let's say different hydrants being active, then put them in a separate configurations. For example, for this configuration, I will set one firefighting demand of 10 liters per second here. I will use data table to set it. And for this configuration, let's set firefighting demand of 10 liters per second to this node. Okay, let's now create scenarios. So I will create 4 different scenarios. You can create any amount of scenarios. These are water demand scenarios. So let's say first scenario I will call winter. Second one I will call summer. The third one I will call summer plus F1 like fire 1. And the fourth one I will call summer plus F2, which is fire 2. And now by default, everything is turned on. You see these checkboxes, you see the blue values, the blue columns in the data table. But for the winter scenario, first of all, I will turn off firefighting demand. I will turn off the tourists. So we have only people and industry. For the summer, I will turn off firefighting demands. For the summer plus fire 1, I will turn off fire 2. And for summer plus fire 2, I will turn off fire 1. Now we have 4 different water demand scenarios. And now we can go to scenario preview. And basically here we can compare different, basically we can run parallel hydraulic calculations. So let's check it. Let's turn on summer. Let's turn on summer plus fire 1 and winter. And now you can see data by data or scenario by scenario in different colors, all the results for that scenario. So red is summer, yellow is summer with fire. You can see how the flows are bigger because we have additional 10 liters per second for fire, and the blue is winter. So you can check it like this, or I prefer it to check it like this so you can immediately compare flows, velocities, head losses, unit head losses, everything is here. And of course, you can also switch to data table for the nodes and compare. Here are the water demands, here are the head elevations and the pressure elevations. And just like for everything in Urbano, you don't have to analyze the whole system at once. You have your selection options. So for example, you can select just this array or just these 2 arrays, and then analyze just that part of the network. And you can see in the yellow scenario, which is the scenario with firefighting demand, we have this higher velocities because of the additional 10 liters per second. So like any other data table in Urbano, you can select it, you can copy it, or you can copy it as HTML, which means that also all these colors will be copied. So let's copy. Let's go to Excel. And here, let's just paste this. And here it is, one really nice report with all these colors copied. So here you can see that for these sections, for this scenario, you have this really, or let's say higher velocities because of the firefighting demand. So that's about it about water demand scenarios. I will also save this report. So let's save it here, and I will give it a name scenarios. Okay, and click Save. Okay, let's close this and let's go back to Urbano. So now we have scenarios. So now when you go, for example, to hydraulic calculation, here the software is asking you, okay, calculate, but according to which scenario? That I showed you before is just a table. The software calculates everything on demand and shows in that table. But as you can see, the results didn't change. The results are still saved for that scenario without firefighting demand. So default is sum of all defined demands, which would be, if I click calculate, you see it's 86, meaning 2 firefighting demands. And you have all of the scenarios here. So for example, let's save the scenario with 1 firefighting demand. Let's calculate. Now you see it's 7614. Let's save it. And now this one is saved in the model. So that's how you can switch between the scenarios. And you can see because of the firefighting demand, we have this pressure drop happening on this part of the network here. And we can also check this higher velocities. So here it is. This is the velocities of 1.5, 1.4, and so on, 1.6 here. So we can check it in the data table. Let's select, for example, this branch here. And here you can see that I will turn off auto zoom. Here we have the higher velocities. Of course, now you could go again to our pipe optimization. And now you will also see here that for demands, you have, just like for the hydraulic calculation, you have sum of all defined demands or according to one of these scenarios. So now you can rerun this calculation and get different or better pipe diameters, but I will not repeat the procedure now. But also I would like to show you this. Sometimes, of course, you will have the overlapping of the labels. You will have overlapping of the labels with the sections or with the nodes, or one label with another. So of course you can move the labels interactively by starting the function move label. You can select the label that you would like to move, select the base point, and basically move that label. Or the option that I prefer is the automatic label reposition, where you can define what labels you would like to automatically move. Let's select just the node labels, and then you can define the rules for moving. So how this calculation works. First of all, the software is rotating by some angle. Default is 30. We can leave 30, or let's say 22.5. So the software is rotating this and finding the position where it won't be in intersection with the elements or with another label. If this cannot be satisfied by making a full circle, then the software will increase the leader. So it will increase a leader by this value. I will set by 1 unit. And then if it again makes the full circle, it again goes the full circle, this time of iterations or trials. I like to increase this to, let's say, 1000 or 2000. It's very quick, so it doesn't matter. And also you can also put some buffer around the labels so that the labels are now not too close one to each other. I like to put 0.5. Select this whole system. Let's click here. And now you can see 5 labels are automatically moved. So there is no overlapping of the labels anymore. So really, really nice and powerful function. Here we had just 5 labels, but just imagine if you had to move 500 labels.